So good morning, everyone. So shall we start the class? So good morning, all of you. Good morning.
Good morning, sir.
Good morning, sir.
Start the class.
Yes, sir.
Okay. So in the last class we have discussed about the electron transfer reaction. The last class we have discussed about the electron transfer reaction. So how to transfer the electron from one complex to another complex. So we have observed here two different types of mechanisms. We have observed here two different types of mechanisms. They are what? One is the inner sphere mechanism. One is the inner sphere mechanism. The second one is the outer sphere mechanism. Outer sphere mechanism. So here what happened? Electron transfer from one metal ligand complex to another metal ligand complex. Okay. So in the inner sphere transfer of electron transfer this complex in between the one of the ligand is acting as a bridged ligand. One of the ligand is acting as a bridged ligand. Okay, so electron transfer from this complex to this ligand. Electron transfer again this ligand to this complex. Electron transfer takes place. That is called what? Inner sphere mechanism. In this mechanism is a three-step mechanism is there. Three-step mechanism. What is the step one? The preparation of precursor complex. Step two, electron transfer takes place. And step three, separation of the two complex. Separation of the two complex. So please go to mute all of him. Mute kellandamma. So clear my voice, all of you. Once again means give the clarity of clear my voice.
Yes, sir.
Okay. All of you go to mute. So in this mechanism, three steps are there. Which mechanism? Outer sphere, inner sphere mechanism. The three steps are there. Step one, step two, step three. Step one is the precursor complex, the preparation, electron transfer, separation of the complex. At the step three, the separation of the complex. Okay, those metal complex or loss of electron. Those metal complex or loss of electron. That complex is accept the bridge ligand. ఏ కాంప్లెక్స్ అయితే ఎలక్ట్రాన్ ని డొనేట్ చేస్తుందో ఎలక్ట్రాన్ ట్రాన్స్ఫర్ అవుతుందో ఎలక్ట్రాన్ మీన్స్ డొనేట్ చేస్తుందో ఇన్ దట్ కాంప్లెక్స్ ఈజ్ ద యాక్సెప్ట్ ఆర్ టేకెన్ ఇన్ ద ఎక్స్ లైగెండ్. ఓకే, ఈ కాంప్లెక్స్ లో ఉన్న H2 ఉంటుంది కదా, అది ఎలక్ట్రాన్ రిసీవ్ చేసుకున్నది తీసుకుంటుంది. ఎలక్ట్రాన్ రిసీవ్ చేసుకున్నది తీసుకుంటుంది. దట్ ఈస్ హియర్ క్లియర్ ఇస్ దేర్. ఓకే, సో దట్ ఈస్ కాల్డ్ వాట్? Inner sphere mechanism. Then outer sphere mechanism. Outer also similar thing. But here what? There is no the formation of bridged complex. Bridged complex form kadu. This is the fourth step mechanism is there. 4 steps. What is that? One is the preparation of precursor complex. That means the oxidizing complex and the reducing complex is connect అయిపోతాయి. Oxidizing and reducing complex both are connected by the dotted line. That is the precursor complex. Second step, this precursor complex is undergoes the activation state. The precursor complex undergoes the activation. That is the in that activation state, that is loss of electron. One is the loss of electron, one is the gaining of electron. That is second step. And the third step, what? Electron transfer takes place. Electron transfer takes place. Okay, here those metal complex is loss of the electron, that is appear the positive charge. Okay, those who are the gaining the electron, that is the negative charge. Edaithe electron ni kolpotundo adi positive ga untundi. That is indicate that plus is nothing but loss of electron, minus is nothing but gaining of electron. Okay, a complex ki minus and రాస్తే అర్థం ఏంటిది? అది ఎలక్ట్రాన్ తీసుకున్నట్టు అర్థం. ఆ కాంప్లెక్స్ మీద పాజిటివ్ రాసిన అర్థం ఏంటి? అది ఎలక్ట్రాన్ ని డొనేట్ చేసినట్టు అర్థం. ఓకే, సో హియర్ indicate that positive and negative charge. One is the loss of electron, one is the gaining of electron. One is the loss of electron, one is the gaining of electron. After that, fourth step. What is the fourth step? The electron means separation of the complex. The separation of the complex. So here O minus R plus O minus. This is the oxidizing complex is gaining the electron, plus R plus reducing complex is the loss of electron. Reducing complex is the loss of electron. So here in the reducing complex, increase the oxidation number. Oxidizing complex decrease the oxidation number. Sorry. Okay, same. Increase the oxidation number of reducing complex, decrease the oxidation number of oxidizing complex. Okay, so in this outer sphere mechanism, this is nothing about the what is the mechanism? Outer sphere mechanism. What is the mechanism? Outer sphere mechanism. So in this outer sphere mechanism is followed the two types of complexes. Two types of complexes followed. One is the self exchange reaction. Self exchange reaction. Self exchange of electron. The second one is the cross exchange electron transfer. Self exchange electron transfer, cross exchange electron transfer. So self exchange is nothing about the two similar complexes. For example, here hexacyanoferrous complex to hexacyanoferric complex. Electron transfer takes place from hexacyanoferrous complex to hexacyanoferric complex, or hexacyanoferric complex to hexacyanoferrous complex. This is what self exchange reaction. This is what self exchange reaction. Now you see here the FeCN6 plus 4 is there. That is the ferrous complex. The self exchange reaction. Example కనిపిస్తుంది clear గా. Self exchange reaction. Okay, what is that? Hexacyanoferric complex to hexacyanoferrous complex, or hexacyanoferrous complex to hexacyanoferric complex. That means similar metals. Electron transfer from similar metals. In between the electron transfer is the similar metals. Here iron, here also iron. Cyanide, both are same. Here to here electron transfer, or here to here electron transfer. There is no bridged ligand. Here there is no bridged ligand. Direct electron transfer takes place. That type of mechanism is what? Outer sphere mechanism. So here this is a self. This type of outer mechanism is same. These 4 steps are involved. Electron transfer kavalante ee 4 steps involved kavali. Okay, so that is the mechanism. This is the example ఏంటిది? self exchange reaction, self exchange electron transfer, self exchange reaction or self exchange electron transfer. The second one is the cross exchange antam. Second one is the cross exchange reaction or cross exchange electron transfer reaction. Okay, in this mechanism the electron transfer occurs between the different metal ions. Electron transfer takes place from different metal ions. So here what is the iron is the one metal ion, and iridium is the another metal ion. Iron is the one metal ion, iridium is the another metal ion. Okay, so iron is the another example. Iron and molybdenum is the another metal ion. Okay, iron to iridium electron transfer, or iridium to iron electron transfer, or iron to molybdenum electron transfer, or molybdenum to iron electron transfer. Okay, so the electron transfer takes place or occur from to to different metals, okay. So this type of transfer reaction is occur in between the what is the name of this reaction? Cross exchange reaction. What is the name of this reaction? Cross exchange reaction. So in this cross exchange reaction also, or follow the or undergoes the this type of mechanism. So this is a common mechanism for outer sphere. The inner kaavachu, outer means not that is the self kaavachu, cross kaavachu. This is the mechanism. Okay, ఇక్కడ పైన చెప్పింది this is the mechanism. అది self కావచ్చు, cross కావచ్చు. Okay, so this type of mechanism can explain the scientist is the Marcus Huss is the scientist. Marcus Huss. Okay, so that is known as Marcus Huss principle. The explaining the outer sphere mechanism. So the proposed scientist is discovered scientist is known as the Marcus Huss. Two scientists. So the name reaction is the Marcus Huss principle. The name of the reaction is Marcus Huss principle. So this is nothing about the electron transfer reaction. I will show that. Okay. Just wait. So this is nothing about the Marcus Huss principle or cross reaction. Another name of the reaction is what? Cross reaction. This is a very important for the 4 marks question, short question. Okay, simple, direct. Okay, that is the Marcus Huss principle. Okay, Marcus Huss principle or cross reaction. So what is the cross reaction here? For example, iron to electron transfer for the molybdenum, iron to molybdenum, or molybdenum to iron. So in this electron transfer reaction takes place in this pattern. That is given one equation. Based on in this equation, prakaram electron transfer anedi avutundi. Okay, so adentidi that is depend on the mechanism paranga untundi. This anta mana mechanism cheppochu. Okay, so electron transfer for same reaction, different metal. Next, second step, electron transfer same metal. Okay, then different metal. That is the K1, K2, K3, different. Okay. So electron transfer, this is the stepwise manner. The electron transfer takes place for the stepwise manner. Okay, that is the equation there is there here. So you can show this, means observe this equation. What is the equation? Log F. Log F is equal to log K1Z. Okay, by 4 log K1 into K2 by Z square. Okay, that is the equation. So here all Wohl's abbreviations are there. Okay, K1Z is equal to rate constant for the cross reaction. That is a small capital K1 and a Z. Then the small K1, K2, the rate constant for the electron exchange species. Okay, so here capital Z, there is a measure of the collision frequency. Okay, F is the close to 1. That means the oxidation state. That means electron transfer, single electron transfer appear here. Single electron transfer close to 1. Okay, this is the Marcus Huss equation. This is what Marcus Huss equation. Okay, this is the applied in this equation. Equation applies to వస్తుంది మనకు. So hexacyano ferrous complex. Here MO, the CN8 is there. C18 is there. Molybdenum is the +5 state లో ఉంటుంది ఇక్కడ. Is the iron is the +2 state. Molybdenum +5 state. Then electron transfer from the +2 to +3 is convert. Molybdenum is the +4 convert. Okay, molybdenum is the +4. +5 నుంచి +4 కి కన్వర్ట్ అయింది. +2 నుంచి +3 కి కన్వర్ట్ అయింది. ఓకే, ఈ విధంగా that is the electron transfer takes place in this manner. Okay, can be participated from the rate constant of the reaction. Rate constant of the reaction, that is the first electron Fe నుంచి Fe star కి transfer అవుతుంది. That is the K1. First electron Fe to Fe transfer అవుతుంది. Then molybdenum to molybdenum transfer అవుతుంది. After that electron overall reaction is the molybdenum నుంచి iron కి or iron నుంచి molybdenum కి electron transfer అవుతుంది. This is called what? Marcus-Hess principle. So once you can observe this equation and read once, you can clearly understand that. This is the very important for the 4 marks question. Write a note on the Marcus-Hess principle. Write a note on the Marcus-Hess principle. Okay, this is one type of electron transfer reaction in between the metal. Then another type of reaction also is there. That is also you can explain that. Another type of reaction. So here we are observe which type of reaction mechanisms. We can observe the here SN1, SN2, SN1CB without breaking metal ligand bond. That is for the octahedral complex. And the square planar complex. Also we can observe the SN2 type of mechanism. At the same time, some trans applications are there. Means trans complexes, cis complexes, different types of complex are appear. So that complex are explained. The 2 theories are there for the square planar complex. Discuss about for the square planar complex. 2 theories are there. One is the what is electrostatic polarization theory, and second one is the pi bond theory. The second one is the pi bond theory. Okay, so this is the electron transfer reaction also is there. We discuss about the electron transfer reaction. So with the 2 types of electron transfers are there. One is the inner sphere mechanism, outer sphere mechanism. Inner sphere mechanism through bridge ligand. Outer sphere mechanism what? Without bridge ligand. Then electron transfer takes place without bridge ligand. So this type of reaction is the 2 type complex are there. One is the so in the inner sphere mechanism, the different are same metal complex. Different are metal complex, but through the bridge ligand. In the previous we discussed about the which cobalt and chromium, different metals. Different metals. Sometimes same metals are involved. Electron transfer bridge ligand ద్వారా జరిగితే అది inner sphere అంటాం. ఈ ligand లేకపోతే outer sphere అంటాం. This is not there, that is the outer sphere. Okay, so outer sphere లో మళ్ళీ 2 types ఉన్నాయి. One is the self exchange, cross exchange. The cross exchange is nothing about the Marcus-Hess is the proposed scientist Marcus-Hess. So this is the electron transfer reaction. The next one is the electron transfer takes place. That is the 2 electrons transfer at a time. Transfer the 2 electrons. Okay, and this type of reaction is the different type of reaction mechanism. Different type. That is the one is the oxidative addition reaction. The first reaction, electron transfer, and at the same time coordination number also increase. For example, Ml4 coordinate complex is bind with the X2, and the formation of Ml2X2 L4X2 complex is formed. Okay, so this is the 4 coordinate complex. So unsaturation is there. ఈ కాంప్లెక్స్ unsaturation ఉంది. అప్పుడు ఏం చేస్తుంది? ఇది ఒక X2 అనే లిగెండ్ తో రియాక్ట్ అవుతుంది. X2 హోమో ఆర్ హెటెరో ఏదైనా కావచ్చు. ఎగ్జాంపుల్ నేను చూపిస్తాను. సో ఈ విధంగా. సో దిస్ ఇస్ వాట్ ఎట్ ద సేమ్ టైం ఇంక్రీజ్ ద ఆక్సిడేషన్ స్టేట్ ఆఫ్ దిస్ మెటల్. ఇక్కడ +1 ఉంది అనుకో, ఇక్కడ +3 అవుతుంది. At the same time increase the oxidation number and increase the coordination number. Ikkada coordination number is 4. Here coordination number is 6. 4 to 6. That is called what? Oxidative addition reaction. Okay, Next, reductive elimination reaction. Second type of reaction also is there. That is what? Reductive elimination reaction. Reductive elimination reaction. Reductive elimination reaction. So here what? Ml6 complex. Ml6 complex or Ml4X2 complex is converted into the Ml4 and X2 complex. Okay, and a 6 coordination complex is converted into the 4 coordination complex. Reductive elimination. So here what? Decrease their oxidation number. ఇక్కడ +3 ఉందనుకో, ఇక్కడ +1 అవుతుంది, ఇక్కడ +4 ఉందనుకో, ఇక్కడ +2 అవుతుంది, +5 ఉందనుకో, +3 అవుతుంది. ఓకే, ఈ విధంగా. దట్ ఈస్ కాల్డ్ వాట్? రిడక్టివ్ ఎలిమినేషన్. టూ టైప్స్ ఆఫ్ రియాక్షన్స్ ఆర్ పాసిబుల్. అంటే రెండు జరుగుతున్నాయి ఇక్కడ. ఎలిమినేషన్ అవుతుంది, రిడక్షన్ అవుతుంది. ఓకే, ఇక్కడ ఆక్సిడేషన్ అవుతుంది, ఎడిషన్ అవుతుంది, ఆక్సిడేషన్ అవుతుంది, ఎడిషన్ అవుతుంది. ఓకే, ఆక్సిడేషన్, దట్ మీన్స్ we are give the oxygen for that reaction. Okay, or removal of hydrogen. Okay, ఈ విధంగా. That means what? Increase their oxidation number. Okay, oxygen is the oxygen, increase the oxygen number. Here removal of oxygen, reductive elimination is nothing but removal of oxygen. That means oxygen remove అవుతుంది, at the same time decrease the oxidation number. I will show an example, then after that we can explain that. Okay, example చూపిస్తాను. Simple reaction, oxidative addition reaction. So electron transfer takes place. Okay, at the same time increase the coordination number also. In the previously, that is the addition type of reaction. Previously ఏంటిది? Substitution type of reaction. ఇప్పుడు ఇంత ముందు ఇప్పటిదాకా మనం డిస్కషన్ చేసింది substitution type of reaction. Now addition type of reaction. Some reactions are there. I will show that all examples. I will show all examples. So just wait. I will share another photo. So this is the oxidative addition reaction. So you observe here iridium complex. Okay, iridium, ppS3, cobalt, chlorine. Okay, the iridium complex. What is the complex name? Is the complex name చూడండి. Oxidative addition reaction. Okay, so this is the complex. Iridium Cl CO ppH3 2. This is a 4 coordination. So here iridium oxidation number is +1. This is what? 4 coordinate complex. In that 4 coordinate complex is addition with the oxygen. So here what? Oxygen అవుతుంది. Oxidative addition, oxygen and addition అవుతుంది. That is called what? Oxidative addition. So in that condition, that is what is the complex? Iridium, chlorine, CO, and means CO is nothing but carbonyl, ppH3 taken twice, O2. That means here oxidation number is +3. +1 నుంచి +3 కి వచ్చింది ఇక్కడ. Previously +1, now that is the +3. Okay, coordination number previously 4, now here 6. Okay, you can compare both. 6 is the somewhat stable, then compare with the 4. Okay, so here 4 to 6, the change the coordination number, increase the coordination number 4 to 6, and oxidation number is also raised from +1 to +3. Oxidation number also raised from +1 to +3. This type of reaction is known as the oxidate. Here two types of reactions are. One is the oxidation and addition. That is called what? Oxidative addition reaction. That is called what? Oxidative addition reaction. So you can check here, observe the example here. So iridium, 2 ppH groups are opposite to, that is the transposition. So here COCl is there, then oxygen, that is a O minus. Okay, that is a 4 coordinate to 6 coordinate, convert into 4 coordinate to 6 coordinate. Then rhodium complex also is there, rhodium. Okay, rhodium complex. Okay, here so another some example. This is called what? Oxidative addition reaction. addition reaction, increase their coordination number as well as increase their oxidation number, increase their oxidation number, increase their coordination number, increase their oxidation number. That is called what? Oxidative addition reaction. This is the example. Some other examples are there. I will show that example. Okay, clear? This is also important for examination point of view. Okay. So the oxidative addition reaction, simple common example. Okay. What is the simple example? Metal Ln complex is addition with AB. Is addition with AB. AB తో addition అయింది. ఇందాక X2 అని చెప్పాను కదా నేను. ఇప్పుడు AB అని చెప్తాను. This is a common reaction. ఇక్కడ ఏంది LN. N is nothing but 4. ఏదైనా కావచ్చు. N. Okay. This is some unsaturation is there. దీనికి అస్థిరత్వం ఉంది. అప్పుడు ఏం చేస్తుంది అది? ఇన్కమింగ్ లిగెండ్స్ ఒక మాలిక్యూల్ తో బైండ్ అవుతుంది. దట్ ఈస్ వాట్? AB is the molecule. AB is the molecule. Okay. So for example, increase their coordination number 2. 2 coordination number increase అయింది. Previously N. Here N plus 2. N plus 2. That means 2 addition. 2 ligands are addition is takes place. Addition is takes place at the same time. At the same time, increase their oxidation number also. Increase their oxidation number also. So the A and B are considered the negative charged species. Consider the negative charged species. Okay. That is a molecule. One of the molecule. AB and a molecule negative charged species consider చేసుకొని that is bind with means attack with the this complex MLN complex. Increase their coordination number as well as increase their oxidation number. That is called what? Oxidative addition reaction. Oxidative addition reaction. Okay. Next example. I will show the examples. So almost chapter is over. So here example is the tetrachloroplatinum complex. Tetrachloroplatinum complex is bind with the Cl2. Is bind with the Cl2. Then formation of hexachloroplatinum complex. Then formation of hexafluoroplatinum complex. So here oxidation state of platinum is plus 4 to plus 2 to plus 4. The oxidation state of platinum here in the previously how much? Plus 2. That is addition of Cl2. Okay. 2 minus is addition. That is converted into the plus 4. What is the coordination number? 4. After addition, what is the coordination number? 6. Simple thing. Okay. Increase the coordination number plus 2 plus 4 to plus 6. Increase the oxidation number plus 2 to plus 4. This is called what? Oxidative addition reaction. Everything is there. You can read once. Okay. So very clearly there. So here, which type of metals are undergoes the oxidation? Similar generally, which type of metals in the transition elements? Transition elements are generally undergoes the oxidative addition reaction. Transition metals, all the transition metal is nothing but coordination complex. Some coordination complex are undergoes to the their transition means oxidative addition reaction. Which type of in general the d orbital is above half filled. The d orbital is the above half filled or maximum filled. So here iron. So you can observe here which type of metals. Iron, ruthenium, osmium. This is the iron family antam dini. Iron family. Cobalt, rhodium, iridium. Cobalt family. These are transition elements. 3D, 4D, 5D elements. And nickel, palladium, and platinum. Nickel, palladium, and platinum. So here frequently we can discuss about the platinum gurinchi ekkuvaga maatladtam. That is the their four coordination is a stable complex and they explain their mechanism అని ఆల్రెడీ చూసాం కాబట్టి సో మనం ప్లాటినం జనరల్ గా ఎక్కువ ఉంటుంది. అది అన్ని ఫామ్ చేస్తాయి. అందులో ప్లాటినం కి ఎక్కువ ఉంటుంది. ప్రయారిటీ ఎక్కువ ఇవ్వాలి. దట్ ఈస్ ద clearly explain that and some heavier metals, that means 4D 5D series elements. Okay, so some examples are there here. You can observe the example. So you can observe these all are undergoes the oxidative addition reaction. These all complex are undergoes the oxidative addition reaction. So iridium I will already explain. Then next rhodium. So here what is the addition molecule CH3I, methyl iodide, ఇక్కడ methyl iodide, here Br2, H2, O2. So మన O2 చూసాం ఇందాక. Okay, so these all are undergoes to the oxidative addition reaction. These all are the addition molecule. These all are the addition molecule. These all are the 4 coordinate complex. These all are the 4 coordinate complex. These all are the 6 coordinate complex. 6 coordinate complex. That means 4 to 6. Change their oxidation number 4 to 6. Change their oxidation number 4 to 6. So this is nothing about the oxidative addition reaction. Oxidative addition reaction. దీనికి opposite oxidative elimination reaction. దీనికి opposite what? Oxidative elimination reaction. Elimination, that means what? 6 coordinate complex. 6 coordinate complex is converted into 4 coordinate complex. Elimination takes place in the loss of one molecule. AB అనే molecule ని loss అవుతుంది. Loss of AB molecule. 6 is counted into 4. At the same time, decrease their oxidation number also. Decrease the oxidation number of metal here to here -2 decrease అవుతుంది. Okay, -2 coordination number decrease అవుతుంది, -2 oxidation number decrease అవుతుంది. Decrease the their oxidation number. Okay, -2, and decrease the coordination number is -2. That is called what? Reductive elimination. Okay, reduction takes place at the same time, elimination also takes place. Reduction and elimination both takes place simultaneously. That type of reaction is known as reductive elimination reaction. So different types of reactions are there. One is the oxidation reaction, reduction reaction. Third one, redox reaction also is there. Redox. What is the mean by redox reaction? The oxidation and reduction takes place simultaneously in that particular reaction. It's called what? Redox reaction. Next, fourth type, oxidative addition reaction. Oxidation and addition both are simultaneously takes place. That type of reaction is known as oxidative addition reaction. The fifth one is the reductive elimination reaction. Reduction and elimination both are takes place simultaneously. That is called what? Reductive elimination reaction. Okay, that is the elimination reaction. So that is also one example is there. I will show that example. Just wait. So these all are the addition reaction. Okay, one addition examples of oxidative addition reaction. So many examples are there. Different examples are there. 4 coordinate AB వచ్చింది, అది ఈ విధంగా bind అయింది. So the addition of this molecule depend on their stability. So ఇక్కడ మనం మిథైల్ ఐయోడైడ్ చెప్పాను కదా, CH3I, అది 3 ప్యాటర్న్ లో అవుతుంది. సో 3 diastereomers with P6 to P. P means the bulky groups. These 2 bulky groups same side unte cis అని చెప్తాం. So 2 bulky group, PPH3 is nothing but triphenyl phosphine, PPH3, triphenyl phosphine, bulky group. That 2 bulky groups are same side unte, that is the cis antam. Okay, 3 diastereomers. What is the meaning of diastereomers? Diastereomers is nothing but not mirror image and not superimposable. That is called what? Mirror image. అది mirror image రాదు, at the same time superimposable కాదు. అంటే దీన్ని mirror image కాదు, దీని మీద పెట్టిన superimposable కాదు అది. ఓకే, superimposable అంటే అది తీసుకెళ్లి ఇది మొత్తం తీసుకెళ్లి దీని మీద పెట్టినప్పుడు సేమ్ ఉంటే దట్ ఈస్ superimposable. నాట్ superimposable అండ్ నాట్ mirror image. mirror image కూడా లేదు. ఇక్కడ అర్థం పెట్టండి, different కనిపిస్తాయి. There is no mirror image and not superimposable. That is called what? Diastereomers. అంటే ఇక్కడ CH3 వచ్చే పొజిషన్ ని బట్టి మనం 2-3 విధాలుగా చెప్పొచ్చు. ఓకే, PP6 పొజిషన్ లో ఉన్నప్పుడు ఈ విధంగా అన్ని these all are the diastereomers. ఓకే, అండ్ PP ఆపోజిట్ గా ఉన్నప్పుడు కూడా ఉంటుంది ట్రాన్స్ పొజిషన్ లో. 3 isomers with P trans to P. Here P6 to P. ఓకే, ఈ విధంగా ఒకసారి చూస్తే అర్థమవుతుంది. ఇక్కడ ఎక్స్ప్లెనేషన్ ఏం అవసరం లేదు. సో Transposition in the cis position. Trans is the always stable. Trans is always stable. Compare with the cis. Compare with the cis. అంటే ఇక్కడ ఏంటిది వచ్చే గ్రూపులు అనేవి మిథైల్ అయోడైడ్ గ్రూప్ ఈజ్ ఎక్కడ బైండ్ అవుతుంది? 2 పొజిషన్స్ ఉన్నాయి. ఇక్కడ మెటల్ కి ఇరిడియం కి 2 పొజిషన్స్ ఉన్నాయి, 2 వేకెట్ ఆర్బిటాల్స్ ఉన్నాయి. బట్ దట్ ఈస్ స్టేబుల్ గా ఫామ్ కావాలి అంటే ఆ రెండు వచ్చి ఎక్కడెక్కడ యాడ్ అవుతాయి, ఎక్కడెక్కడ అవుతాయి, ఈ విధంగా పాజిబిలిటీస్ ఆర్ దేర్. దీస్ ఆల్ ఆర్ పాజిబిలిటీస్. ఓకే, దిస్ ఆల్ పాజిబిలిటీస్ లో ట్రాన్స్ ఉన్నప్పుడు ఎక్కువ స్టేబుల్ గా ఉంటుంది. ట్రాన్స్ గా అంటే పీపీ బల్కీ గ్రూప్స్ ఆర్ ట్రాన్స్. Bulky groups are trans. At the same time, the incoming groups also trans. Incoming also trans. CH3 I రెండు trans లో ఉన్నాయి. PPS3 PB రెండు trans లో ఉన్నాయి. ఈ all 9 isomers లో ఇది స్టేబుల్ గా ఉంటుంది. This is the stable isomer. This is the stable isomer. అంటే మీన్స్ వచ్చే గ్రూప్స్ ఆపోజిట్ లో ఉన్నాయి. At the same time, 2 bulky groups also ఆపోజిట్ లో ఉన్నాయి. 2 bulky groups. That is means what? PPS3 is a bulky group. PPS3 is the opposite in PS3 is the trans. P trans to P trans to P stable. అన్నిట్లో ఇది స్టేబుల్ అంటే స్టేబుల్ ఐసోమర్. స్టేబుల్ ఐసోమర్. దిస్ ఇస్ నథింగ్ వాట్? రిడక్టివ్ మీన్స్ ఆక్సిడేటివ్ ఎడిషన్ రియాక్షన్. ఆక్సిడేటివ్ ఎడిషన్ రియాక్షన్. ఓకే, నెక్స్ట్. సో హౌ మెనీ మెంబర్స్ ఆర్ దేర్? ఓన్లీ 24 మెంబర్స్ ఆర్ దేర్. So next one is a reduction elimination reaction. That is same, opposite, quite opposite the oxidative addition reaction. Then another type of reaction is there, that is the insertion reaction అని చెప్తాం. Insertion reaction. That means rearrangement takes place. Rearrangement. Okay, rearrangement. At the same time means addition అవుతుంది. At the same time insertion అవుతుంది. Addition అవుతుంది, insertion అవుతుంది. Both are possible. Addition and insertion అంటే మీన్ ఇన్సర్షన్ మీన్స్ rearrangement. Okay, first attack అవుతుంది, then after that based on the stability rearrangement takes place. That type of reaction is called as insertion reaction. ఇది అంత ఇంపార్టెంట్ కాదు, సో జస్ట్ ఉంది కాబట్టి చెప్తున్నా. ఇన్సర్షన్ రియాక్షన్, రీఅరేంజ్మెంట్ takes place. So that reaction is insertion reaction. సో దాన్ని క్లియర్ గా ఒక ఫోటో పెడతాను చూడండి. సో హియర్ ఇన్సర్షన్, చేంజ్ ద గ్రూప్స్ అంటే ఇక్కడ పొజిషన్ చేంజ్ అవుతుంది, ప్లస్ ఎల్ రావాలి. అప్పుడు ఏంటిది 6 మీన్స్ ఆల్రెడీ 6 కోఆర్డినేషన్ నెంబర్ ఇస్ దేర్. బట్ ఎల్ కూడా రావాలంటే ఏంటిది? సమ్ రీఅరేంజ్మెంట్ టేక్స్ ప్లేస్. ఓకే, the carbonyl group is converted into the what means carboxylic group ga convert ayindi chudandi. Insertion, internal changes are occur. That is called what? Rearrangement. This is the insertion reaction of CO. ఈ విధంగా ఉంటుంది. This insertion reaction, their mechanism ఈ విధంగా ఉంటుంది. అంటే ఏంటిది? ఇక్కడ L రావాలి మనకు. L is addition or addition కావాలి, నాట్ సబ్స్టిట్యూషన్. అయితే రిప్లేస్ చేస్తుంది, నాట్ సబ్స్టిట్యూషన్. ఎడిషన్ కావాలి. ఇస్ అ 6 కోఆర్డినేట్. ఓకే, సో సమ్ రీఅరేంజ్మెంట్ టేక్స్ ప్లేస్. ఏమవుతుంది? ఈ ఆల్కైల్ గ్రూప్ దీని పైకి వెళ్ళిపోతుంది, ఏదో ఒక CO పైకి వెళ్ళిపోతుంది. దెన్ దట్ ఈస్ కన్వర్టెడ్ ఇంటు ద కార్బాక్సిలిక్ గ్రూప్. సో హియర్ వాట్? ద 6 coordination is converted into what? 5 coordination. 6 coordination is converted into what? 5 coordination. Then after that L is attacked. L అనేది అటాక్ అవుతుంది. L is attacked in that complex. Then that is converted into the what? 6 coordinate complex. So this type of reaction is known as the insertion reaction or rearrangement reaction. Very very important. So this rearrangement reactions. Okay, next ఇంకో క్లియర్ ఎగ్జాంపుల్ చూపిస్తాను. సో దిస్ ఇస్ ద ఇన్సర్షన్ రియాక్షన్ కి దేర్ ప్రాబబిలిటీ ఎలా ఉంటుంది అంటే ఇప్పుడు ఏది ఇన్సర్షన్ అవుతుంది ఐసోటోప్ ని బేస్ చేసుకుని మనం చెప్పొచ్చు. ఓకే, సో 6 కోఆర్డినేట్ కాంప్లెక్స్ రీఅరేంజ్మెంట్ అవుతుంది. ఈ CH3 అనేది కమింగ్ ఇన్ టు ద కోఆర్డినేషన్ స్పియర్. ఇక్కడేమో ఎక్కడ ఉంది మీన్స్ కార్బాక్సిలిక్ గ్రూప్ లాగా ఉంది. ద ఆల్కైల్ గ్రూప్ ఇస్ ద కార్బాక్సిలిక్ గ్రూప్ లాగా ఉంది. దట్ ఈస్ ఎంటర్ ఇన్ టు ద కోఆర్డినేషన్ స్పియర్. దట్ ఈస్ ఎంటర్ ఇన్ టు ద కోఆర్డినేషన్ స్పియర్. కోఆర్డినేషన్ స్పియర్ లో ఎంటర్ అయింది. ఎంటర్ అయినప్పుడు ఒక CO ని బయటికి పంపించాలి, అంటే రీఅరేంజ్మెంట్ చేయాలి. సో ఇక్కడ ఐసోటోప్ ఉన్న CO ఉంది, CO+3 కార్బన్ ఐసోటోప్ ఉంది. ఓకే, ఐసోటోప్. సో దట్ ఈస్ ద డిపెండ్ ఆన్ దేర్ స్టెబిలిటీని బేస్ చేసుకుని one is the major, one is the minor product form అవుతుంది. One is the major and one is the minor product form. Okay, rearrangement, there is no change their coordination number, there is no change their coordination number, but sometimes that is complex unstable గా ఉంటుంది. కొన్నిసార్లు some complex are unstable గా ఉంటుంది. In that condition that is undergoes the rearrangement. In that condition that is undergoes the rearrangement. So that type of reactions are known as the insertion reactions. The type of reaction is known as the insertion reactions. So based on their positions, that is identify the level position, that is identify the level position. Rearrangement అయినప్పుడు ఏం చేస్తుంది, అది level position ని ఐడెంటిఫై చేస్తుంది. Labile is nothing but what? Unstable position. Unstable level is nothing but unstable complex. Labile complex is nothing but what? Unstable complex. Okay, that means unstable position. Which is the unstable position? That is the suitable position for the rearrangement. Okay, so based on that different types of reactions, the insertion reactions are there. So this is nothing about the reaction mechanism of transition metal complex. This is nothing about the reaction mechanism of transition metal complex. You can read one clearly, you can easily understand that. Okay, this is the black 3 is over. Black 3, reaction mechanism of transition metal complex. So reaction mechanism, the labile complex, inert complex also, the just definition is there. Labile complex, unstable complex or labile complex. Inert complex, stable complex. Stability, inert is nothing but stability. Those metal complex are get the stable, that complex is inert complex. That type of complex in general not involve the reaction. That type of complex are not involve the reaction. Labile complex, unstable complex. The type of complex are involve the reaction. Reaction involve అవుతాయి, fast గా involve అవుతాయి. That is the different types of reactions are there based on their coordination number. So in the organic orientation, different type of reactions are there, mechanisms. Okay, means what? Free radical substitution reaction, free radical elimination, addition, different types of. So here we can discuss about the metal complex. So that is the nucleophilic substitution reaction is majorly 90% of metal complex are undergoes the what? Nucleophilic substitution reaction. Some other reactions are this type of reactions. Rearrangement అవుతుంది, reductive elimination అవుతుంది, oxidative addition అవుతుంది. Okay, electron transfer అవుతుంది. ఇది అదర్, ఇది ఒక 10% ఉంటాయి. Mostly 90% of metal complex are undergoes the what? Nucleophilic substitution reaction. That reactions are we are applying in this chapter octahedral complex. The octahedral complex are SN1, SN2, SN1CB without breaking metal ligand bonds. That is the acid hydrolysis and base hydrolysis reaction చెప్పాము. Next 4 coordinate, that is the square planar complex. 4 coordinate square planar complex are undergoes the substitution reaction. That is the SN2 type of reaction is possible. SN2 is nothing but what? Association mechanism. SN2 is nothing but what? Association mechanism. Okay, so we can explain the trans and cis complex, which is a major complex. Trans complex or cis complex, that is a trans effective series. On ligand series is there in the material is there. I will also explain that in that class, that series. Based on that series, cis is major sometimes, trans is major sometimes. So how why the trans is major, why cis is major, that is can explain the pi bond theories. That is can explain the that is what theories of the trans effect. One is the electrostatic polarization theory, the second one is the pi bond theory. Two theories are explained. ఎందుకు ఎక్స్ప్లెయిన్ చేసిందంటే ఎందుకు cis trans major explain చేస్తుంది. So this is nothing about this chapter. This chapter also I will send the that group. Already share the chapters. 2 chapters are shared. Okay, you can print out or
Yes,
write
sir.
that is. Then this is also I will send today. Okay. So black 3 also complete. Then black 4 is there. That is can discuss about the next session. Okay.
Okay, sir.
So all of you clearly understand this chapter? క్లియర్ గా అర్థమైందమ్మా ఇంకేమైనా?
అర్థమైంది సార్.
ఓకే. సో ద నెక్స్ట్ చాప్టర్ బ్లాక్ 4 నెక్స్ట్ చాప్టర్ లో చెప్తాను. ఇది కూడా పంపిస్తాను నేను ఇన్స్టాగ్రామ్ లో. ఐ విల్ సెండ్ దిస్. ఓకే. అండ్ 10 to 11:30 కదా. సో 11:30 కి క్లాస్ ఉంటుంది. ఓకే, మళ్ళీ జాయిన్ అవ్వండి. ఓకే
సార్ ఎంతకి సార్?
11:30 అనదర్ క్లాస్ ఇస్ దేర్.
ఓకే ఓకే, థ్యాంక్ యూ సార్. ఓకే సార్.
ఓకే
ఓకే సార్. ఓకే సార్. నోట్స్ టెలిగ్రామ్ లో సెండ్ చేయండి సార్ ప్లీజ్.
సెండ్ చేస్తాను.
ఓకే ఓకే, థ్యాంక్ యూ
అట్ ద
సార్.
సేమ్ టైం మీరు పంపించగానే ఒకసారి రీడ్ చేసుకోండి అప్పుడప్పుడు.
ఓకే సార్. ఓకే సార్.
రీడ్ చేసుకుంటే మీకు ఈజీగా అవుతుంది. లేకపోతే మళ్ళీ ఒకటేసారి ఎగ్జామ్ లో చదివారు అనుకోండి, దట్ ఇస్ వాట్ డిఫికల్ట్ అయిపోతుంది.
అవును సార్, అవును సార్.
ఓకేనా?